Welcome to Vision Plus and welcome back to the Senior for Mathematics. We are looking at finding the length of a tangent from a point to a circle. We are doing example 4. Example 4, part A has given us the equation of the circle of x squared plus y squared minus 10y minus 4 equals to 0. So let us draw the circle. We are not drawing accurately, we are just getting a guide. Then we assume that the tangent is at that point. So the tangent is drawn from this point to the circle at this point. And the tangent is from the point 4 and negative 2. So let me call that point B. And then the point where the tangent touches the circle, let me call it point A, just to guide us. But some questions can be specific. They will tell you that it's coming from this point, touching the circle at this point, and the center C. So the center here, we can draw the radius, which is perpendicular to the tangent. Where are the coordinates of the center here? Since we have the equation, we can get the coordinates of the center. Please, this is the expanded equation. Go on and find the coordinates of the center as we learned. But in this case, the coordinates are 0 and 5. These are the coordinates of the center, which you must get when you compare it to the expanded equation of the circle. So after getting the coordinates of the center, now we need the radius. And since it is expanded equation, we know that the formula of C is given by a squared plus b squared minus r squared. C is given here as the sum of constants, negative 4 equals to a. A is a coordinate of the center, which in that case is 0 squared, plus b is also a coordinate of the center, which is 5 squared, and then minus r squared. Then you press your calculator and get for us the value of r. 0 squared plus 5 squared plus 4. So I'm getting my r as root of 29 units. So after getting r, it means this distance now is root of 29 units. We are looking for what? The length of the tangent, which is the distance AB. So this is the length of the tangent AB that we are looking for. Now, for us to get the length AB, this one is already a right angle triangle. So we can find CB to help us find AB. So the length CB, that is the distance between 2 points. The length CB is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared, and put the root. This gives us the now the square root of. Then you come and name the points. Let me call this x1, x2, y1. Sorry. We say x1, y1, then x2, y2. So we substitute for them there. x2 is 4 minus x1. x1 is 0 squared plus y2 is negative 2 minus y1 is 5 squared. Then you press the calculator. 4 minus 0 squared plus negative 2 minus 5 squared. I'm getting root of 65 units. After getting the length CB, then we apply Pythagoras theorem. So that we can find the length AB. Pythagoras theorem states that in this case, this AB squared plus AC squared equals to CB squared. It says that the sum of the squares of two shorter sides, which are AB and AC, equals to the square of the longer side, in this case CB. Then we substitute. AB is what we are looking for, So we shall have AB squared plus AC. AC is the radius, which is root of 29, but the formula says square equals to CB is root of 65, but the formula says squared. Then you press the calculator and get AB. So root of 65 squared minus root of 29 squared. I'm getting 6. So the length AB equals to 6 units. That is 65 minus 29 years. Therefore, the length of the tangent which is now the distance from A to B or from B to A is 6 units. We are looking for the length, and we know that length is a scalar quantity. It only has the magnitude and the direction is not defined. It's just a distance between 2 points. So that is the solution to part A. Let us go. Part B, the equation or the circle is defined by x squared plus y squared plus x minus 3y equals to 0. This is the circle. So let us sketch a circle. Then we say, assuming the tangent is touching the circle at that point, that is the line of the tangent. And the tangent is coming from which point? The tangent is drawn from point 3, negative 4. From point 3, negative 4. So let me call this point B, or you can define it in any way you want to make the work easier. You can call it C, D, or any letter. Now let me call this point where the tangent meets the circle point A, which you can choose to call any other point. And then the coordinates of the center is there. Then the radius is that distance from the center to the point of tangency. This is right angle. So what are the coordinates of the center of this circle? If you look at this circle, it is in the expanded form. So you can find the center and the radius. So in this case, the center is negative half and 3 out of 2 and 3 out of 2. Please go on and use the other way of comparing coefficients, and I'm sure you'll find these answers. So the coordinates of the center are negative half and 3 out of 2. Now, let us get the radius. This is the expanded equation, and we know that in the expanded equation, C is given by A squared plus B squared minus R squared. But if we look here, there is no constant term. Constant term is the term that does not contain any unknown. That means our value of C in this case was 0. So 0 equals to, what is A? A is negative half, but we are squaring it plus. What is B? B is 3 out of 2 squared minus R squared. So we solve that and we find R. So negative half squared plus 3 divided by 2 squared root. So I'm getting my R here, my R as root of 2.5. R is the square root of 2.5 because I have squared plus 1.5 squared. Yes, I'm getting R as root of negative 2.5. If you press the calculator, it is a very long number, 1.8 something. So you can leave the answer in this format. Or someone could have R as root 5, root of 5 out of 2, because this gives us 2.5. They are the same. So to save the space we have here, let me say our R is root of 2.5, which is the same as this fraction. Now we are looking for this length, which is the length of the tangent AB. So for us to get it, we need to know the hypotenuse, which is the length CB. Use a ruler please, which is the length CB. So to find CB, we name this x1, y1, x2, y2. So now the length CB, use the formula given by x2 minus x1 squared plus y2 minus y1 squared. Then you substitute for x2 is 3, then minus x1 is negative half squared plus y2 is negative 4 minus y1 is 3 out of 2 squared. And then you press the calculator. It is 3 minus negative half squared plus negative 4 minus 3 out of 2 squared, square root. So I'm getting the length CB as root of 42.5 units. This answer is okay. But then we prove I have 3 plus 1.5 squared plus negative 4 minus 1.5. Oh, I've seen a mistake. So 3 minus negative 5 squared plus negative 4 minus 1.5 squared. Yes, it is correct. So this is the value of CB. So the length CB is square root of 42.5 units. Now here we can apply Pythagoras theorem because it is a right angle triangle and we have two sides. Pythagoras theorem. Pythagoras theorem. That means that we shall say the length, the sum of the squares of two shorter sides equals to the square of the longer side. So this gives us AB squared plus AC squared equals to CB squared in this case. So we are looking for the length AB. So now the AB squared plus AC squared. AC squared is root of 2.5 squared equals to CB. This is root of 42.5. The formula says squared. Then we press the calculator. That is simply 42.5 minus 2.5. So I'm getting the length AB as the square root of 40 units. That is the square root of 40 units because root of 42.5 squared minus root of 2.5 squared. Yes. Let me take the square root. Therefore, the length of the tangent, which is AB, drawn from the point 3, -4, is root of 40 units.